Hey everyone, welcome back to my channel. So in today's video, we are going to talk about one important question which is related to your interviews. And this question is mostly asked in the embedded domain companies like NXP, Qualcomm, Harman, Samsung and other embedded companies. And it is also asked in the other interviews also. So what is the question? So the question is, what are the various compilation phases of a C and C++ program? That means we are going to study today that what are the various steps involved when we want to convert a C or C++ program into a executable program. So what do I mean by this? So I hope many of you know what is compiler in our software development process. So basically compiler is a program or the software which actually converts a program which is written into your high level language code, and it converts that particular code or the program into a executable code or the executable file. So the program can be in any of the high level language like C, C++. Okay, so here we are talking mostly about the C and C++. Okay, so basically compiler is a software or a program, or you can say it is a translator which actually converts or translate a program which is written into a high level language, okay, into a machine language code or the low level language code. So basically this low level language code is called the executable file. So basically, let's say you have written a program into C language, okay, and now if you want to find the output of that program which you have written into C language, then the compiler will first convert this program into a some format which can be understood by your computer or by your CPU so that you can see the output. So you will take the help of the compiler and it will convert that source code, okay, which is written in either C or C++ language, into a machine friendly code, okay, that will be known as low level language code. Okay, so sometimes it happens that compiler converts your this high level language code into a low level language code, and low level language code can be like assembly code also, or it can be machine language code also. Okay, so basically both these are the example of the low level language code. Okay, basically I have explained what is low level language code, okay, or you can say what is assembly language code, what is machine language code in one of the other video. You can find the link of this video in the C programming playlist. Okay, so you can find the link in the video description below for that playlist. Okay, so do watch it. So for example, here you can see we have the program, okay, and this program is written into a C language and the program is saved inside test.c file. We want to see the output of this code. So to find the output of this code, okay, so that computer can understand and give us the output, we first have to compile this program. That means we have to convert this program, okay, into a executable file. Okay, so we will take the help of the compiler. So how we can like invoke the compiler and ask him to convert this program into a exe file, okay, or the executable file. So we will say gcc, this is the name of the compiler, then we can write the source file name, okay, that is test.c. Then we can give any new name. Okay, so any new name can be like test also, okay, or we can give any test2 or something other name for the executable file which will be getting as the result for the output of this compilation process. Okay, so if we hit enter, here you can see we got test2, okay, test2.exe. okay, so this is the executable file because we are working on the Windows, so we got .exe file. If we run this command on the Ubuntu or any of the Linux operating system, then we will simply get test2. Okay, we will not get .exe, right? So that will also be an executable file. So now after compilation process, we have got this executable file. We can later on run it, right? So our compilation process is over. If we want to find the output, we can run this test2. Okay, so we can just write test2. Okay, so if we hit enter, here you can see you get the output. Okay, because there was no space. So now if we again compile, okay, now if we again run, here you can see we have got the two output, area of the circle and circumference of the circle. Okay, but the question is, when we are saying that compiler is a translator, okay, it converts .c file or any of the high level language code into a executable file. Okay, so here we have written that it converts high level language code to assembly code also. Okay, assembly and machine code converts assembly and machine code comes under the low level language code. So the question is, where is the assembly code here? We have just run this command and we got the executable file, but where is the assembly code? We can't see any assembly code, right? And we have also talked about the preprocessor directive in our C programming. Okay, so what happens with the preprocessor directive actually? Okay, so basically we are going to all these steps which are involved behind the scene of the compilation process of a C and C++ program. That means we are going to see how actually a C and C++ code is converted into a executable code. That means what are the various steps involved in this translation, okay, of a C and C++ program into a executable code. Okay, what are the various small steps or the softwares which are actually involved when we click the compile button on any of the IDE, or you can say when we write the just command gcc, okay, test.c -o test, then what are the various steps which are going behind the scene, okay, in the compilation process of a C and C++ program. So all those tests or all those softwares we are going to see in this video, and we are going to see what are the various intermediate files which are created during this compilation process. And we are going to see what is the content present inside those intermediate temporary files, okay, which are actually created during this compilation process. Okay, we are going to open them and we are going to see what is written inside those files, okay, and what information we can get from them. Okay, and after understanding all these steps which are involved in the compilation process, we are going to see what is the work of the loader. Okay, basically this loader is not involved in the compilation process, but I will be telling you at the end of the video why do we need loader. Okay, now before going forward, let me ask you why it is important to know the various steps behind the scene which are happening in the compilation process. Is it not enough to just get the executable file by compiling a program, okay, by writing just a command, okay, gcc command, and or you can say by clicking the compile button on any of the IDE, we can just get the executable file. Okay, is it not enough? Why we want to know the various steps behind the scene? So the answer is, if we are working with the low level programming or the system programming, or we are writing the device driver, or let's say we are working in the companies which are working in the, you can say, embedded domains, then we have to deal with all these steps. Okay, we have to analyze the assembly code in between, that what information we can gather from the assembly code after we compile a .c program. Okay, so this assembly code is the intermediate file which we get actually after we compile a .c program or the C++ program into a .exe. Okay, so we have to analyze that file also. Okay, and we have to gather some information, we have to make some changes, or we can like debug our code in a better way. Okay, so that's why we need that information. And sometimes it happens that we just want to get the assembly code only. Okay, we do not want the direct executable file. Okay, then how we can do that? Okay, we must know that how we can get the assembly code also, right? So we do not want the you can say executable file directly. Okay, so this was one of the basic reason why we want to know all the steps which are behind the scene happening in the compilation process. Okay, so now let's start and understand practically what are the various steps involved in the compilation process of a C and C++ program. So here you can see we have a C program which is stored inside the test.c file. Okay, the same way we can have a C++ program also saved inside .cpp file. Okay, so this is known as the source code. Okay, and we want a executable file. Okay, let's say test.exe, or you can say if we are working with the Linux, then we want like a.out file or the executable file which we can run on the Linux operating system. Okay, and here you can see we have this compiler. Okay, so along with the compiler we have the various other softwares which are involved in the compilation process of a C and C++ program. So here you can see when we write this command gcc test.c -o and then test. Okay, so actually we first encounter the preprocessor. Okay, then the work of the compiler comes. Okay, then assembler comes, and then linker comes, and then finally we get test.exe or the executable file. Okay, depending on the operating system. Okay, so basically this file is known as, you can say, source code. Okay, or the this is the input file. Okay, so any high level language program can be written inside here. Okay, and this is the executable file that we are getting as the output after the compilation process is over. Okay, so basically when we give this test.c file, first it goes to the preprocessor. Okay, so preprocessor, assembler, linker, compiler, all these are softwares. Okay, so basically sometimes if you're working with Windows, then you download, let's say, any of the software like Dev C++, okay, so that you can like write the program and you can compile the program. So Dev C++ is like a bundle which says the like you can say IDE, okay, so that you can write the program, and it has also the compiler, okay, which is actually coming when you download that Dev C++, okay. And let's say if you are working with, you can say, Linux operating system, then you download the GCC compiler, right? So with that compilers, the linker also comes, okay. And if you are working with the you can say embedded devices, so sometime it happens you download the tool chain, okay. And tool chain consists of compiler, linker. So many times it happens the assembler comes with the device, actually the device which we are working with, let's say any IoT device which we are working with, assembler comes with that, okay. And sometimes it happens in the compilation process only preprocessor is there, compiler is there, okay, and linker is there, okay. The work of the assembler, you can say, it is removed or it is done by the compiler only, okay. So depending on the scenario, okay, the steps can be reduced also, okay. But these are the, you can say, basic steps, okay, which you must know, and any interviewer will be happy to know if you understand all these steps, okay. So here you can see first we have the test.c file, right, which we give to the preprocessor, okay, when we compile the program. So preprocessor will do some work, okay, which I will tell you later, okay. And then preprocessor generates a temporary file that is known as test.i, okay. This is the pre-processed code. After this is done, then compiler comes, okay, and compiler takes this test.i file, okay, and it converts that into a assembly code, okay, that is the test.s file, okay. So this test.i file is also a high level language code only, okay. There is no, you can say, machine language code inside this test.i. It is also a high level language code, but there is some difference, okay, from this source code file, okay, we'll see, okay. So compiler converts this preprocessed code or the high level language code into a assembly code, and we know that assembly code is actually a low level language code, okay. This is actually a machine dependent code, okay. So assembly code is generated by understanding the machine on which you are actually compiling your program, okay. So for the Intel CPU, your assembly code will be different. For AMD CPU, your assembly code will be different, okay. So basically compiler is a software which basically generates your assembly code depending on which machine, on which CPU you are generating this assembly code, okay. Then assembler comes and this takes this test.s file as the input, that is assembly code as the input, and convert your assembly code into a object code, okay. So object code can have the extension as .o or .obj, okay. So many times it happens that if you are working with the Windows, then you have .obj, and if you are working with the Linux operating system or any of the flavor of Linux, then you have the object file as .o extension, okay. So depending on, both are the object code only. So assembly code also and the object code also, both are, you can say, the low level language code, okay. And finally your linker comes, okay. So this software do some work, okay, of linking, I will tell you later, okay. And it links some other files also with this test.o file, okay. And after linking all those different files with this test.o file, you get a final executable file, okay. Let's say test.exe, okay, or a.out, okay, depending on the operating system, okay. And that is your final output of the compilation process of a C and C++ program, okay. And later on, if you want to run it, you can just run that program, okay, that is run that executable, okay. So this file can be run, okay. This object code cannot be run directly, okay. This test.exe or a.out, it can be run, okay. Now the question is, with the help of this command, you can just directly get this .exe file, okay. You cannot get these temporary file. Now if you want to get these temporary files also, then there are two methods to get these files. One is this command, okay, gcc space minus vol, then space minus save minus temps, okay. And then the source file name, okay, your file name is test.c that you want to convert, minus o any file name, okay. Any file name is any file name that you want to give for the executable, okay. Let's say you want to get the executable with the help name test, then you just give test, okay. If you want to get test2 as the executable file name, then you can just give test2, okay. So this will give you this file also, this, and this file also, right? All the files. And the other method can be like you can create these files individually, okay, individually with the help of different commands one by one. Okay, so what are those different commands? I will tell you later. Let's understand all these steps one by one in detail. Now, before this, let me tell you that you can find various playlists on my channel like C programming, operating system, numerical methods, some live session videos, interview experiences, GATE exam, lead code solution related videos. So do watch these videos and like, comment, and share these videos also. So basically, when you compile your program, so behind the scene, first the pre-process software comes. Okay, so this basically takes your test.c file, that is source code, and it converts it into test.i file. And what basically it actually do all these four things. That is, it removes the comment from your program. It also expand the macros and the included files, okay, which you have used in your test.c file. And it also, you can say, removes the condition compilation directives, okay, and whatever conditional compilation directives they are saying, it actually help to achieve that task. So what do I mean by this? So here you can see we have this program, and here it is finding the area and the circumference of the circle, right? So area is pi r square, circumference is 2 pi r, okay? So this is the radius that we have taken. Now pi is a constant value, so we have specified pi value using the macro, okay? So if you do not know what is macro, I will talk more about the macros in the later videos, okay? So basically here you have used a comment, okay? So you know that in C programming or any of the program, you can use the comment, so that with the help of comment, your reader can understand your program very well, right? So here you can see I have written this command, okay? Now if I hit enter, okay, so here you can see I have got many different files, test.i, test.o, and test.s file, right? And the final file is test.exe because I have given the name of the executable file as test, okay? So basically this test.i, what is present inside this? So this test.i is the output of the preprocessor after it converts your test.c, okay? So what is inside this test.i? Here you can see this test.i contains a lot of code, okay? Here you can see, okay, there are many code, okay? And if you go down, okay, here you can see you have this code, right? This is the same code that you have written, okay, in the test.c, right? Here you can see, okay? So if you just see, all the comments are removed, right? Before the main, you have used the stdio.h has defined pi 3.14. These are not present, okay? These are not present in test.i. The same way, the comments, okay? The comments are not present. This macro and this find the area, these comments, they are not present here, okay? So what actually this preprocessor has done, it has removed all the comments because they are just for the readability for the user. They are not of any use for the other process of the compilation, okay? So they have been removed. And this preprocessor has done also one thing, whatever stdio.s file has the code, okay, what is the code written inside the stdio.s, all that code has been pasted here, has been pasted, okay, in place of stdio.s. So this all code is the code which is present in stdio.s. So this all code is pasted here, okay? So this is the work of the preprocessor directive, okay? And the other work was condition compilation directive related work, okay? So what does that mean? So here you can see we have the another file test2.c, and here you can see we have this if def and end if. So basically these are the, you can say, condition compilation directives, okay? Here you can see I have written has defined area. So I will not talk about much about this, okay? In this video, I will talk about all this condition compilation in the other video, okay? So here I just want to tell you that this condition compilation directive help us to tell that whether we want to compile this particular statements or not, okay? Depending on some conditions, okay? So if you have written this has defined area line, okay, and you have enclosed this inside this has if def area, then this will be compiled, okay? Otherwise it will not be compiled. That means if you write this, okay, that means you have just commented this, okay, has defined area, okay, that means you have just removed. Then what will happen in the .i file? You will not find this code, okay, because area is not defined here. Okay, so basically this whole code will be removed from your .i file. If you want to see, yes, let me tell you. So here I am compiling this program again, okay, and my source file is test2.c, right? Test2.c, and let me give the name of the executable as test2. Okay, so you will see here, okay, you have test2.exe, test2.i. Okay, so if you see test2.i, okay, this is the same code. Okay, if we go down, okay, we want to know the last code. Okay, here you can see double r equal to 3 is okay, and you have this only 2 pi r. Okay, so if you see 2 pi r, this code is not present, okay, because this was not present. Okay, so this condition compilation thing, it is also seen by the preprocessor directive. Okay, I will talk more about the condition compilation in the later videos. Okay, and the last work of the you can say this preprocessor was, it actually expand the macros. So this pi is actually a macro, okay, or you can say a symbolic constant. So the value of this pi is placed here. Okay, wherever pi this word will be present, this 3.14 will be placed. Okay, so this line is also removed because its work is done, right? So here you can see now 3.14 is placed here. There is no hash defined pi. Okay, so these macros are also expanded by the preprocessor, right? So I hope you have understood that what is the work of the preprocessor. Now let's move to the next phase. So now this test.i, that is the pre-processed code, it is given to the compiler. Okay, and compiler takes this code as the input, and this high level language code present in test.i file, it is converted into the low level language code, that is assembly code, that is test.s file. Okay, so compiler basically your checks the syntax error also as per the programming language. So if you have written the .c program, okay, so compiler will check all the syntax related error according to the C language syntax. Okay, it will also check the spelling error. Okay, if you have done any of the spelling error in your C programming code, then it will also check and it will give you the error, right? Okay, so let's see and just see what is present inside this test.s file. Okay, so here is one sample code. Okay, this will help you to make you understand about the assembly code. Okay, that is the .s file. So here in this code, I am adding the two numbers a and b. A is having 2, b is having 6. So the sum will be storing the answer 2 plus 6, that is 8. Then I have printed this sum. After that, I have just used the if and else. Okay, so if the value of a is greater than 2, then I have printed hello, otherwise world. Okay, so let me like create all the temporary files, okay, using that gcc minus -vol command. Okay, so here you will see all the files have been created. Okay, area2.i, area2.o, area2.s, and area2.exe. Okay, now we are interested here in the area2.s file, that is the assembly code for this C program. Okay, what will be the assembly code for the C program? Let's see. So let me open area2.s. Okay, and for your understanding, let me open these two files .c and .s simultaneously. Okay, so here you can see this is our area2.s file, okay, for this .c program, right? So here you can see this is our area2.s file, that is our assembly code corresponding to this C program. Okay, so in this assembly file, okay, or in this assembly code, we have various sections actually. These LC0, LC1, LC2. Okay, here you can see these are actually, you can say, sections, or sometimes these are also known as labels. Okay, so you can see we have many other labels, LFB13. Okay, and here you can see we have underscore main. Okay, so this underscore main is actually the starting of your main function. Okay, here this is your main function in C program. In assembly code, this main is written as this. Okay, so here this main code is starting from here, right, in .c file. In assembly code, this is getting started from here. Okay, and in assembly code there are various mnemonics. Okay, so actually this move, okay, move L and L, okay, this call, these all are called as mnemonics. Okay, these are the like symbolic names. For example, here you have plus operator, right? A and B you are adding. So in your assembly code, corresponding to this addition, you will have this mnemonic, this symbol add.
A double D. L is for long. Okay. So the same way, if you are subtracting A minus B, then you will have SUBL, something like that, subtraction. Okay. So these are like mnemonics. Okay. So there are many mnemonics. This JL is like jump, less than, equal. Okay. These are also mnemonics. Okay. This compare L, CMP means compare. These are all mnemonics. Okay. So basically here you can see, if we are adding this A and B, so we have this add. Okay, A double D add. Okay, and these are actually registers names. Okay, we are not talking much about the assembly code, or you can say we are not understanding the details of this assembly code here. Okay, so I'm not going into much detail, but just to tell you, here you can see, after adding the two numbers, I'm printing their sum, right? So after addition, okay, and there are many other things which are occurring behind the scene. Okay, so there are many registers, some values are pushing, some values are getting popped. Okay, so these all things are happening, and after that you can see here there is call printf. That means this printf function, okay, is being called. Okay, this statement is written inside your assembly code. Okay, that please call the printf function so that we can print this sum variable. Okay, and after that you can see we are comparing the two values, a and 2, right? So in C language, these values are compared using CMP. Okay, and then accordingly, if a is greater than 2, then we are jumping to this statement. Okay, if a is not greater than 2, then we are jumping to this statement. So we have many jump statement in your assembly code, JLE. Okay, jump. Okay, so I hope you have got some idea that how this code, okay, looks like in assembly code, and what are these different mnemonics, okay, means. Okay, now one interesting thing I want to tell you is, here you can see we have hello and we have world, right? So these are like the strings, okay, which we are printing as messages in our assembly code. Okay, here you can see we have this hello and word also present. Okay, these are the like strings. Okay, these are terminated by null character. Okay, and these lc1 lc2 are like the labels. Okay, and here you can see we have again many labels, jump, le, l2. Okay, then here l3, lc1, l2, l3 is here. Okay, so it is something like uh, it is saying ki, okay, if a is greater than 2, jump to some label. Okay, jump to label l2. Okay, come to label L2. In L2 we are saying jump to, you can say LC2, okay, something like that, or move to LC2. Okay, then we will sing, okay, LC2 is here. Okay, so it is saying, okay, come to world. Okay, something like that. Okay, so in this way your small C code, okay, your small C code has been converted into a big large code of the assembly, right? So that means if your area2.c file is of, let's say, 1 KB, is this area2.s file, it may be larger than 1 KB. Okay, because your code is getting larger and larger. Okay, so I hope I have given you a very clear and the basic idea about the assembly code. Okay, so let's move to the next stage or next phase of the compilation process. Now, before moving forward to the assembler, let me tell you that compiler is also a big software. It basically consists of many small steps, okay, which help it to convert this high level language code into the .s, that is the assembly code. So basically these are the various steps. We have the like inside the compiler we have like lexical analyzer, syntax analyzer, and so on. Okay, and after all these phases are complete, your high level language code, that is this test.i, or you can say test.c, this code is converted in your assembly code. Okay, so we are not talking about all these phases of this compiler. Okay, this we will see later in the next videos. Okay, so just I want to tell you in brief, okay, that in computer science we have a subject, that compiler. Okay, compiler design. In that subject we study all these steps, okay, inside the compiler, okay, which help it to convert this high level language code to the assembly code. Till now we have seen, let's say we have this program. Okay, let's say we have this a equal to 50. Okay, a greater than 50, then print hello, otherwise print world. So you get some assembly code, okay, which is something like this thing. Okay, we have many jump statement. Okay, we do not have this if and else in the test.s file, but I have just written just for the understanding. Okay, so this type of code which have the various mnemonics like add, subtract, move, jump, this code is actually called as assembly code. Okay, and this is the low level language code which is dependent on the CPU, okay, on which we are compiling our program. Okay, Now let's move to the assembler. Assembler basically takes this assembly code and convert this into the object code. Okay, and this object code is actually a machine code again. Okay, and this is the relocatable machine code. I will tell you what is relocatable means. Okay, so basically this object code cannot run by itself. That means if we double click this test.o file, this will not run. Okay, and this will not give us the output, okay, that we want. Okay, basically after linker does its work, then only we can get the, you can say, executable file. Okay, so basically assembler convert this work. Okay, we have this assembly code, right? And we get this relocatable machine code. Okay, so basically in, you can say, in simpler sense, some addresses, they are attached with your assembly code, okay, by the assembler. Okay, so these, you can say, these are the various you can say addresses 0 1 2 3 4 5 6. Okay, so let's say here it is saying jump 6. Okay, so this is like sixth line. Okay, if a is greater than 50, jump to this sixth line. Okay, and it is saying jump 7, that is here. Okay, so the addresses will be, you can say, attached with your code. Okay, and this will be present inside your object code. Okay, and this is relocatable. So what does this relocatable mean? Relocatable means that this code can relocate, or it can be placed inside your main memory at any address. Here it is starting from the 0 address. Okay, so it may happen that at 0 address inside your main memory there is no space. Okay, there is some other program. Okay, so what will happen? Your code can be put, let's say, at the address number 100. Okay, start from the address number 100. So this line will be placed at 100 address, then this will be placed at 101. Okay, then this second line will be placed at 102, that is 102 address, and so on. Okay, so that means this code has changed its place, its address. Okay, here its address start from 0, but in main memory its address, the starting address of this code, will start from the address number 100. Okay, so this is meant by this code is relocatable. This is adjustable code. Okay, I will again talk more about relocatable code in the later videos. Okay, now before going to the linker, again I want to tell you that this object code is actually a binary code. Okay, it is the code which is like code consisting of ones and zeros. Okay, this is basically not a assembly code. Okay, this code is having the binary code only. So basically, as you can see, .s program, okay, .s file into your editor. Okay, you have seen in the visual editor, but you cannot open this test.o file using a normal text editor. Okay, you have to use the, you can say, hex editor to view the content of these files. Okay, and again in those, you can say, hex editor, you cannot directly understand all the things. Okay, you should have some understanding of the low level language code, then only you can understand what is the meaning of those you can say these binary codes. Okay, so basically you cannot open this test.o file. Let me show you. Let's say if we take any of the o file. Okay, so area2.o. okay, so if I try to open it, here you can see the messages file is not displayed in the editor because it is either binary or uses an unsupported text encoding. Okay, so it is saying, do you want to open it anyway? So if I just say okay, okay, built-in text editor, okay, I have used. So if I use the built-in text editor to open this file, here you can see you are not getting any like readable content. Okay, there are some garbage things like, okay, so some of the things are like null, some of the things like are like some special characters, right? So this cannot be understood by a normal text editor. Okay, some special hex editors are used to view these object files. Okay, now let's move to the next phase. So next phase is linker. So linker basically link your various other object files with your this test.o file, and after combining or linking all those object files, it give you executable file. Okay, so basically the what is the content inside the various object file? So basically, why do we need this object file also? So as you have used printf function in your test.c file, right? And printf function is used to print some content on the screen or any value of the variable. Okay, so you just use that functionality using the printf function, but you do not know how the printf function actually prints something on the screen. Okay, your program or the executable should know that how I can print something on the screen, right? So what happens, your compiler writer, they have already written that functionality inside a file which is called as printf.o file. Okay, and inside that file all that information is present. So basically your linker will link or add that information with this test.o file. So scanf function, it takes the input from the keyboard. How keyboard will be like taking the data from you, and it will be giving your C program. That functionality is present inside scanf.o. Okay, so this information will be added with this test.o file. Okay, so basically this printf.o, scanf.o, these are the compiled file, pre-compiled file, pre-built files. Okay, these are given by your compiler writer. So some person has written printf.c. Okay, inside that everything will be written, that how anything will be printed on the screen. Okay, what is the code of the printf function. Then that person has actually compiled your printf.c, and after assembly you got printf.o. Okay, and then they upload that code on the, you can say, any website. So when you download any compiler, you get the printf.o, scanf.o, and any other object files also. So now linker will actually take this printf.o, scanf.o behind the scene, and it will link. Okay, so linking can be like static or dynamic linking. Okay, so we are not talking much more about this static dynamic linking in this video. We'll see later in the other video. So after doing all these things, a relocatable machine code, that is the you can say executable code, it will be you can say obtained. Okay, so basically you have this test.o file, you bundle together all the other files, and you get a relocatable machine code. Okay, basically as you have added other functionality, okay, so your code has some changes. Basically before this executable, your code was saying jump 6, that is here. Now there is some other line added here, so everything has shifted. So now you will be saying jump 7. Okay, this is was saying jump 7. Now your executable will be saying jump 8. Okay, because we have shifted one line, okay, below. Okay, so these addresses will be changed, okay, in your final executable file also. Okay, and this is again a binary file. Okay, so this cannot be seen in your normal text editor also. Okay, so I hope now you have understood that how this compilation process actually works and what are the various steps involved. Now let me tell you how you can create these files individually by different commands. So these are the different commands that you can use to generate these different files. So from test.c, you want to get test.i, you can write gcc minus e, your test.c source file, minus o test.i. Okay, or any new name. Okay, you can just give any new name, let's say hello.i also. Okay, and if you want to get .s from .i, you can use gcc minus s test.i, that is this file. Okay, then if you want to get this test.o file from this test.s, you can use minus c option. Okay, then test.s, you will get test.o. Okay, and if you want to link, okay, various files, okay, and you want to generate this test.exe, then actually it depends whether you are doing static linking or dynamic linking. Okay, so the command is something like gcc minus o. Okay, but there are some other things which will be written after this minus o. It depends on the static or dynamic linking process. Okay, so I'm not telling the exact commands here, okay, because it depends on the static and dynamic linking. Okay, that we will talk in the other videos. Okay, so basically these three steps or three commands here are important. Okay, so here you can see we have the test.c file. Okay, and we have no other intermediate file for the test.c. Okay, so I'm using minus e test.c minus o test.i. Okay, I'm generating this test.i. Okay, so see here test.i is generated, right? Okay, now I want to generate test.s, that is assembly file. Okay, from this file, so I will use the minus s option. Okay, test.i. Okay, so here you can see test.s is generated. Okay, test.s is generated. Okay, and now after this I want to generate the which file, object file. Okay, so how I can generate the object file? Using the minus c option. Now this c is small. Okay, you have to take care. Okay, test.s. So here you can see test.o is generated, right? So I hope now you have understood all the steps that how you can generate the various object files. Okay, now before ending the video, let me tell you what is loader. Okay, So basically loader is a software which actually loads your requested file from the secondary storage into your main memory. Okay, and it is a part of the operating system actually. Okay, so basically how this loader actually works. So basically you have any file which is present inside your any drive. Let's say you have the D drive and you have like any executable file, or let's say you have any .txt file. Okay, so when you double click that file, so that file is actually open up, and you can see the content of that file, right? So basically what happens, let's say if you like double click this test.exe, okay, after your compilation process is over, okay, you get test.exe. Okay, now if you want to run that file, you want to find the answer of your program, okay, then loader will come into role. So when you double click your test.exe, okay, or any of the executable file, then the loader, which is actually part of OS, it actually loads, okay, or place this test.exe in your main memory. Okay, wherever the space is present, it will place that file. Okay, and finally what will happen, this content, okay, from this main memory, it will be read by your computer or by your CPU. Okay, and one by one your instruction will be read and your output will be shown on your monitor, right? So overall, we can say that we have this executable file, which is a binary file, right? And this binary file will be loaded by the loader inside your main memory, wherever the space is present. And it will be then read by your CPU one by one, line by line from here, and the output will be shown to you. Okay. So basically, when I was telling you that this code, this exe is relocatable, it means that here this 0 address is the starting address of your program, right? But let's say uh, 0 address is filled, okay, 1th address is filled, okay, these addresses are filled, okay, this is filled, only this space is you can say empty. So what will happen, your loader has the responsibility that it will actually map this line, okay, 0th line to your 100th line, okay, because space is started from 100, okay, this space is empty. Okay, so here only your loader can place your program. Okay, then this 1th line will be mapped to 101. Okay, that means this code has been relocated to a different memory address, right? It is starting from now 100. Okay, earlier it was starting from 0. So this is the meaning of relocatable. Okay, again, I will talk more about the loader and its working in detail in the other videos. Okay.
So I hope you have enjoyed this video. So please like, share and subscribe this channel and press the bell icon for further notification of the videos. See you in the next video with much more details of this compilation process and the other related topics. So till then, goodbye.